Hi friends, in this video, the next topic is simple loop analysis for synchronous motor. Here, the simple loop diagram will explain you what is the function of motor. And I said you in alternator, if you listen alternators carefully, the synchronous motors is nothing, everything is same. And even in simple loop analysis also, I said you the only change is load and supply. Let's see here again. So, for example, North Pole and South Pole, North Pole and South Pole. And here my armature is there. For example, this is my armature of synchronous motor. Here also my armature of synchronous motor is like this. Of course, the flux flows from North Pole to South Pole is like this. This is the constant flux, DC excitation flux, right? In this, we have a armature coil. This is my armature coil. These are my armature coil. This armature is connected to slip ring 1 and brush 1 and slip ring 2 and brush 2. I said you already. Here also slip ring 1 and brush 1, slip ring 2 and brush 2. Is it okay? Now, generally, this armature coil having two conductors, AB and CD. Here, AB conductor connected to slip ring 1 and brush 1. CD conductor connected to slip ring 2 and brush 2. These brushes are connected to AC supply like this. This is the AC supply. For first half of cycle of supply, generally the supply is like this, right? This is the input. Then what is the armature current or armature EMF? We have to see. So here for positive, that's why the current is flowing like this. Nothing but from supply to the brush. From brush to the slip ring. Brush to the slip ring. Slip ring to the armature. Slip ring to the armature. This is the flow. And armature to the, again this is a closed loop, armature to the slip ring to the brush is like this. So the flow is from supply is AC and brush AC and slip ring also carries AC and armature also AC. After 180 degrees, so here this is again connected to supply, but this is for negative half cycle. This is for negative half cycle. Here also AB conductor, actually these conductors are rotating. That's why this is D and this is C and this is B and this is A when these conductors are rotating. So this CD conductor connected to slip ring 2 and brush 2 again. This AB conductor connected to slip ring 1 and brush 1. Here the negative half cycle, that's why current is alternating in nature. So see here, the flow of current is like this. The flow of current is like this. See here, the flow of current is like this. This is the flow of current. Nothing but from supply to the brush brush to the slip ring to the armature again. Then what is the armature current actually? See here, for first half of cycle, the armature current is from A to B or from C to D. For next half of cycle, the armature current is from D to C. Nothing but the input is AC and the armature current also AC. And here the power flow is from supply, first of all, supply to the brush to the slip ring to the armature. You should remember all these things. This is simply the simple loop analysis of synchronous motor. You know very well, the only change is load and the supply for motor and generator, right? Basic principle. Generally, what is the basic principle of motor? Do you know? Tell me that first. Whenever a current carrying conductor, what is that? Whenever a current carrying conductor placed in a stationary magnetic field or simply magnetic field, I am placing that a current carrying conductor in a magnetic field, then it experiences a force. What is that? It experiences a force or torque. It may be force or torque. Nothing but, once see here, for example, this is my magnetic field with north pole and south pole, and here the magnetic field is like this with some flux density B. And in this magnetic field, I am placing a conductor which carrying the current I. A current carrying conductor placed in a magnetic field, then it experiences a force. That force, according to Lorentz force equation, who that? Lorentz force equation, F is equals to B I L sine theta. What is B, sir? Yeah, B is the flux density of the magnetic field. What is I? The current carried by the conductor. What is L? The active length of my conductor. What is theta? Can you anyone? What is theta? Very good, very good. Theta is the angle between flux density and the current. Theta is an angle. This angle is in between the flux density and the current. This is the force developed in this conductor. So I am writing here, according to Lorentz force equation, F is equals to B sine theta. If theta is equals to 90 degrees, you will get the maximum force. Yeah, up to now this is completed because this is a motor. So motor will changes. What it will change? From voltage and current to speed and torque. Nothing but it will produce the torque or a force. But here in this motor, another concept is there, back EMF. What is this? What is back EMF? Yeah, exactly. Back EMF nothing but the EMF induced in the motor. Is it? Are you mad? What the motor will do? Motor will develop the torque, not the EMF. Is it okay or not? But what is this back EMF? Once see here, whenever a current carrying conductor placed in a magnetic field, it produces a torque or a force. Due to that force or a torque, the conductor will rotate with some v velocity. Due to that force or a torque, the conductor will rotate with v velocity. Now once listen after this v velocity, this is a rotating conductor. Yes or no? Because of force or a torque, it is rotating with a speed n. Then this is a rotating conductor which is placed in the stationary magnetic field. When a rotating conductor placed in a magnetic field, it produces EMF. That EMF is called back EMF. Sir, why it is called back EMF? Because this EMF acts in opposite direction to the supply voltage. This acts in opposite direction. That's why this is called counter EMF or back EMF. The EMF equation is same again. There is no any change. 4.44 phi F T Kp and Kd, everything is same. But this is in opposite direction, that's why it is called back EMF. So what is the conclusion? In every motor, what happens? If you take a motor, in every motor, generator action will take place. What happens, sir? Here, generator action will takes place, which produces EMF, which is in opposite direction to the supply voltage. This is the condition. This is the statement. In every motor, generator action will take place, which produces EMF, which is in opposite direction to the supply voltage. That EMF is called counter EMF or back EMF. This is the actually what is the basic principle of my synchronous motor. But synchronous motors are not a self-starting motors, right? Let's see about that. Thank you.